Okay, this is your Algebra 1A Semester 1 exam review. Number 1, Natasha worked at a diner for $10 per hour last week and already had $42 in her bank account. She paid $206 for a prom dress, and the equation 206 equals 42 plus 10h represents this problem. How many hours did she work to pay for the prom dress, right? So we're solving for h here. So it helps us set it up. And then we just want to solve using algebra. Obviously, 2x equals 42 plus 10h. First thing I want to do is subtract 42 from both sides of my equal sign. I'm trying to get h by itself. So this goes away. 206 minus 42 is 206 minus 40 would be 166 minus 2 is 164 equals 10h. And then we want to divide by 10, right? We've got, move it over here, 10h equals 164. I want to get h by itself. So I'm going to divide by 10 here, divide by 10 here. And she needs to work about 16.4 hours if she's making $10 per hour, right? Plus she already had 42 saved up, so together all that money would total the $206 for her prom dress. So 16.4 hours. Number 2, or you could say 17 hours, right? She's got to work over 16 hours, so you could just round it up and say she'll make a little extra money if she just works the full 17. Number 2, translate the following sentence into a mathematics equation. The sum of 10 and 5 times a number is the same as the difference of the number and 6. So for me, I always like to find where the equal sign is, right? So is the same as, that's my equal sign. So everything before that is going to be its own equation, and everything after that's going to be its own equation. Anytime you see the words a number, right, in math, that means you replace it with a variable. And I always use x, but you can use whatever you want. Okay, so the sum of, what does sum mean? We're adding. What are we adding? Look for the and sign. The and sign tells us what two things we're adding. So here's the and sign. So we're adding 10 and 5 times a number, which is 5x. Okay, so the sum of 10 and 5 times a number, so 10 plus 5x equals, and comes my equal sign over here, the difference of, so that means I'm subtracting what two things? Look for the word and. Here's the word and. So I'm subtracting what's in front of and what's after and. The number, the same number I've already used, which is x, and 6. And I'm finding the difference, so that's minus. Okay? And all it said was to write the equation, so we are done. 10 plus 5x equals x minus 6. Okay? Number 3, create an equation, same type of problem. Create an equation to show how to solve this problem. Thomas rented 2 bicycles, which were late for return by 6 days. His fine for being late was $18. How much was he charged per day per bike for being late, right? So he rented 2 bicycles, and they were 6 days late, right? So 2 bicycles times 6 days late times whatever the fee per bicycle was. Okay, so I'm going to call it F for fee, right? So all that together equaled $18. That would be our equation, right? So 2 times 6 times F. If I multiply 2 times 6, I get 12. So actually this would be 12F equals 18. $12. 2 bicycles times 6 days is 12, not $12, 12. 2 bicycles times 6 days, that's 12, times whatever the fee per bicycle was per day is equal to 18. And then we can solve for F at the end. So it says how much was he charged for being late? Divide by 12, divide by 12, these go away. F equals 18 divided by 12 would be 9 over 6, which would be 1 and 6 in one time. 3 over 6, 1.5, 150. So it's $1.50 per bicycle per day, right? So he has 2 bicycles. So if it's $1.50 per bike per day, that's $3 per day. And he was late 6 days. So $3 per day times 6 days equals $18. That's what his total was. Okay, we're just kind of working through and thinking through the problem. All right, number 4, George makes $5 per autograph, and we're going to call the number of autographs he signs A, and $8 per hour working as an actor. And we're going to call that W for each hour he works as an actor at a local theater. He needs $730 for rent. Create an equation to show how much he needs from his income for autographs to have enough rent. Okay, so how much he needs for autographs to have enough rent? So we need to solve for A, I guess. So his total rent is $730. So to equal $730, he makes $5 per autograph times however many autographs he gets, plus $8 per hour working as an actor, right? So here's our equation. And then it says create an equation to show how much he needs from his income for autographs to have enough for rent. So we want to solve this for A. We want to get A by itself. Here's our equation. $5 times however many autographs he gets, plus $8 times however many hours he works acting, should equal $730. So how many A's does he need and how much W's does he need? It doesn't tell us how many hours he worked as an actor, so we're just going to rearrange this equation, right? So I'm going to subtract 8W from both sides of my equation. These go away, so I'm going to have 730 minus 8W equals 5A. And I want to get A by itself, so I need to divide by 5. So I'm going to end up with A equals 730 minus 8W all divided by 5. This describes how many autographs he needs, right? And once we know how many he needs, then we can multiply it by 5, and that tells us how much money he needs to make from autographs alone. Okay, hopefully that makes sense. Number 5, the equation 4P equals 12S plus 16 represents the cost for 4 people P to enter an amusement park. What step would you take to find out how much the cost will be for one person? All right, so we have 4P equals 12S plus 16. 4 people to enter the amusement park. 4 people. What steps would you take to find out how much the cost would be for one person? Well, if we don't want P to be 4, if we just want it to be 1P, we would just need to divide by 4. And whatever I do on one side of my equal sign, I got to do to the other side. So I'm going to end up with, these 4's cancel, P equals 12S divided by 4 plus 16 divided by 4. And I can even simplify that. P equals 12 divided by 4 is 3. So that's 3S plus 16 divided by 4 is 4. So for one person to enter the amusement park, it's going to cost 3S plus 4. And we don't know what S is. Maybe the cost to get in plus like food or something. I don't know. But this would represent one person. If 4P is 4 people, we just want 1P, so we had to get rid of that 4 by dividing. All right, number 6, solve the following equations and explain each step using appropriate properties. This is not multiple choice. This is actually a long process. I need to get a sheet of paper here. We've done this a lot. This is your properties of inequality that we've talked about. You just actually have to physically write it out, and it does not give you much room here. All right, so let me scoot it up a little bit more. For this first one for A, 5 times 4x minus 3 minus 18 equals 7. First thing we need to do is distribute, right? So I'm going to have 20x minus 5 times 3 is 15. And then I still have that minus 18 equals 7. That was my distributive property. You have to tell for each step, you have to tell what property you used. Okay, then the next step down, I'm trying to solve for x, so I want to combine my like terms. So negative 15 minus 18 is negative 33. So 20x minus 33 equals 7. And going from this step to this step, the only thing I did was replace this with what it was equal to, right? So that's substitution. Okay, next step, again, I'm trying to get x alone, so I want to get rid of this minus 33, so I'm going to add 33 to both sides of my equation. 20x, the negative 33 gets canceled, I add 33 to 7, so I get 40. Since I just added to both sides of my equation, that's the addition property of equality. Add prop of equal. Good enough for me. And now I have to get x alone, I have to divide both sides by 20. So x is going to equal 40 divided by 20 is 2. And since I had to divide both sides to get my answer, that's the division property of equality. Sorry, running out of room. Division prop of equal. So that's all we're doing. We're just solving it, but then we're stopping after each mathematical step and telling what property we used, right? So let's do the next one. Oops. B. 3 times 2x minus 7 equals 19x. First thing I need to do is get rid of parentheses. Straighten my paper up here. So I'm going to distribute. So 3 times 2x is 6x. Bring down my minus sign. 3 times 7 is 21. And then I keep everything else the same. So all I did here was distribute. That's the distributive property. And I do not care if you abbreviate. That's fine, as long as you know what it means. Okay, next I'm trying to get x alone. So I need to get rid of minus 21 by nope, just kidding. I was thinking this was 19. Next, we have x's on both sides of our equal sign. So I need to get rid of the smallest x. So I'm going to subtract 6x from both sides of my equation. So I'm going to be left with negative 21, because the 6x went away, and 19x minus 6x is 13x. And since what I did was subtract 6x from both sides, that's the subtraction property of equality. Okay, next I need to get x by itself, so I'm going to divide by 13 on both sides. So I'll have negative 21 over 13 equals, and the 13s cancel here when I divide. So I get x equals negative 21 over 13. That was, since I divided on both sides, that was the division property of equality. And actually, I can't leave my answer like this. I have to flip-flop the two sides. So I'm going to put x here equals negative 21 over 13. And whenever you switch the two sides of the equation, what property says you can do that? The symmetric property. I know that was kind of a tricky one. Go back and read your properties from the very beginning of the year when we went over all those properties of equality. I think it was chapters 1 and 2, maybe chapter 1 or 2. Okay, last one. C. 5x plus 6 equals negative 30x plus 1. Unlike the other two, there's nothing to distribute here. We have x's on both sides, so we need to get rid of the smallest x. So first thing I'm going to do is add 30x on both sides of my equation. This guy's going to get canceled out, and 5x becomes 35x. Okay, I want to get x alone, so I need to get rid of this 6. So I'm going to subtract 6 from both sides. Oh, sorry. First thing I need to do is, this is the subtraction property of equality. All right, I subtracted, oh no, just kidding. That's the addition, sorry. Addition property of equality, because I added 30x on both sides of my equation, right? And then this negative 30x got canceled, and this 5x became 35x. So when you add the same thing to both sides, that's the addition property of equality. Now I want to subtract 6 from both sides of my equation. So I'll end up with 35x equals 1 minus 6 is negative 5. And that's the subtraction property of equality. And then the last thing I need to do is divide to get x by itself. I need to divide both sides by 35. So I'm going to have x equals negative 5 over 35. That's the division property of equality. And then lastly, I want to simplify that. I can divide the top and the bottom by 5. So I'm going to get x equals negative 1 over 7. And that's just substitution. I didn't divide both sides of the equation by the same thing. That would have been the division property. All I did was take one side of the equation and change the way it looked. Replaced it with something it was equal to. So that's substitution. Okay, so that's all you had to do for problem 6 on your review. All right, then problem 7, solve 1/5 x equals negative 13. To get rid of a fraction in front of a variable, you have to multiply by the reciprocal. So we have 1/5 x equals negative 13. To get rid of 1/5, I want to multiply by the reciprocal. So I'm going to multiply by 5 over 1. I just flip it upside down. So I have to do the same thing here. Multiply it by 5 over 1. And 5 over 1 times 1 over 5 equals 5 over 5, which is just 1. So I'm left with 1x, right? This kind of gets canceled out. So I'm left with x equals, and then negative 13 times 5. Negative 10 times 5 is negative 50. Negative 3 times 5 is negative 15. 50 and 15 is 65, so it's negative 65. That's my solution there, right? I just separated the 13 into 10 plus 3, multiplied it by 5. 5 times 10 is 50. 5 times 3 is 15, so I got 65. And then, of course, everything was negative, so it was negative 65. Hopefully that makes sense. Number 8. Solve 4 over 7x equals 12. Same exact thing. 4 over 7x equals 12. To get rid of 4 over 7, but leave the x, I have to multiply by the reciprocal. So 7 over 4. So I got to do the same thing here. 7 over 4. So here, 7 over 4 times 4 over 7 gives us 28 over 28, which is just 1. So this leaves us with 1x. Here, I'm going to make this 12 over 1, and to multiply fractions, I go straight across the top, straight across the bottom. So 12 times 7, 10 times 7 is 70, 2 times 7 is 14, so 84. And then 1 times 4 is 4. And then can I simplify 84 over 4? Yeah, 84 over 4 is just 21. So my answer here is 21. Right? I can divide the top and the bottom both by 4. 4 goes into 84, 21 times. 4 divided by 4 is 1, so my answer was 21. Okay, number 9. The expression 4 plus C represents the pounds of candy Tamara had after she collected 4 pounds from a piñata at a party. What does the C represent? And this is multiple choice, so you're just picking one. Okay, so 4 plus C represents the pounds of candy she had after collecting 4 pounds from the piñata. So she collected the first 4 pounds. C represents the extra pounds of candy she collected. C represents the extra pound she collected. So it's not the total pounds she collected from the piñata. The pounds of candy she had before she collected from the piñata, pounds of candy she had in it. No, pounds of candy she had after she collected from the piñata. Pounds of candy Tamara had after she collected 4 pounds from the piñata. So the total is 4 plus C. C is just what she collected. So it would be this one, sorry. I was thinking that D here meant the same thing as A. She had 4 pounds of candy, and then she collected more from the piñata. Then she collected more from the piñata, and that gave her total. So she had the 4 pounds of candy, plus she collected some from the piñata. That's C. So C is the pounds of candy she collected from the piñata. Okay, page 2. Number 10. Man, my camera's funny. All right, what's the domain for each relation shown? Domain is all of your x values, right? So here's my x-axis. What's the x value for all of these dots? Where are these dots along the x-axis? Well, to get to this dot, I have to go back 1, 2, 3, 4, 5, 6, 7. So this has a domain of -7. This one, I have to go back 1, 2, 3, 4, 5. This one, I had to go back -3. This one, I had to go back 0. This one, I had to go forward 2. And for this one, I had to go forward 1, 2, 3, 4, 5. So my domain, all of my x values here are, I'm going to put them in little squiggles, -7, -5, -3, 0, 2, and +5. That's my domain. All right, here my domain is all my x values. That's easier to see. And I don't have to repeat any. If I had another -3 here, I wouldn't have to write -3 twice. It's just asking which numbers on a number line do you use in your domain. You're just listing all the numbers at once. So -3, -1, 2, 4, and 5. And you can put them in squiggles, like I said, but you don't have to. Number 11. Determine whether each graph shown is a function and it's not multiple choice. So we want to use the vertical line test. So I'm going to go here, 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 right? Anywhere I draw a vertical line through this graph, I'm only going to cross this roundy-moundy thing here, this graphed round thing, one time. I'm never going to touch it in more than one spot when I draw a vertical line. So yes, this is a function. Okay, what about this line? If I draw vertical lines through this line, am I ever going to touch it in more than one spot? Nope, it only crosses over that diagonal line in one spot, so yes, this is a function. What about C down here? If I draw a vertical line, look there. I drew a vertical line and I touched this curvy graph here in 2 spots. So that does not pass the vertical line test. You can only pass it in one spot, pass your graph in one spot with the vertical line test if it's a function. So this is not a function. What about this circle? Can I draw a line anywhere and pass more than one point? Yep. And through a lot of places actually, right? Yeah, there's a place I can cross when I just touch one spot, but there's also other places where I touch more than one spot. So this is not a function. Vertical line test.